Right, we're now ready to learn about a new Python type, which is the list. So we're going to see the basic list syntax, how to create our own lists, list methods, and we'll look at slices and indices, which is going to be very similar to the same thing when we met it for strings. Now what Python lists do is they represent what we would call in mathematics a sequence. So they have an order, and you can have repeated elements in your list if you like. To create lists in Python, you use square brackets. So here's an example of how we might do it. If we want to create a list called myList, which contains the numbers 1, 2, and 3 in that order, then you do it with this syntax here. And when you run this, that will create a list with 3 elements, 1, 2, and 3. And here is another list. This time, this list consists of a whole bunch of very different things. So I want to illustrate here that a list doesn't have to have just elements of one type and one type only. You can mix elements of different types. You can even have a list within a list. So here we have a list whose first element is a string. Then we have a few copies of a number, so the same number 3 times. Then we have a list containing -0.1, and finally we even have a function. So absolutely any Python object can be an element of a list. Okay, so let's check. We can do list equality, for example. We can check if my list is equal to 1, 2, 3, and indeed it is. And to illustrate that lists are ordered, we'll check whether my list is equal to 3, 2, 1. This is going to be false because the order really does matter. Lists are not sets. Okay, let's look at some of the things that we can do with lists. So you remember when we met strings, we learned that you can concatenate 2 strings using the plus symbol. Concatenate means put one of them after the other one. So make a new list, which it results from putting the 2 lists together. So here I've got 2 lists. The first one consists of the numbers 1, 2, 3, and the second consists of the number 4, 5, 6. I'm concatenating them using plus, so the result will be the list 1, 2, 3, 4, 5, 6, as you can see when I run it. There's also a special way to add something to the end of the list, and that is a list function, or rather a list method called append. So in order to add 4 on the end of my list, so remember my list was 1, 2, 3, to add a 4 on the end to create the list 1, 2, 3, 4, you could do this by doing my list plus the list that just contains 4. But actually it is faster, it is more efficient to use the append list method, which just adds a 4 on the end automatically. So when I call mylist.append 4, what that does is add a 4 to the end of my list. So on line 2, when I print my list out, you'll see it's now become 1, 2, 3, 4. Now this notation is a little bit strange, mylist.append 4. We haven't seen this before. You should think of it as meaning append brackets mylist 4. So it applies the append function to mylist and 4, and the meaning of the append function is that it modifies mylist by adding 4 on the end. Functions that you call in this way with this dot notation are called list methods. There are lots and lots of functions in Python for dealing with lists. We're going to see only a very few of them. And one of the most important is a function to get the length of a list, which is the len function. So if you do len, L-E-N, of a list, it prints out the number of things in that list. So len 1, 2 would be 2. And this really is the length, so just the length. It doesn't mean how many distinct elements, like in a set, it just means how many elements are there. So the length of this list would also be 2. Here we have the empty list. The empty list is another legitimate Python list, and the length of the empty list here is going to be 0. There we go. So it's sometimes useful to know how to make the empty list. You just do it with 2 square brackets with nothing in between them. When we learned about strings, we also learned how to access a particular element of a string. So you'll remember that if you wanted the initial character of a string, and the string was called s, then you do that with s square brackets 0. Exactly the same thing works for Python lists. You can get element I of a list A using a square brackets I, but you have to remember that Python lists start with position 0. So the first thing in the list, the initial thing in the list, the thing on the left, is the one at index 0. So remember my list, well actually my list is not 1, 2, 3, 4, is it? My list is now 1, 2, 3, 4 with a 4 on the end. But my list square brackets 0 would be the element on the left of that list, which would be 1. Okay, and if you wanted the last element in the list, then you could do that with my list element number 3. That would be 4. Okay, on the other hand, if you try and access a list element which doesn't exist, like element number 4, you can see that will be an error, right? There are only 4 things in this list, so the valid indices are 0, 1, 2, and 3. This is telling you list index is out of range. That means you tried to access an element of a list which didn't exist. So, for example, my list 2 would be okay, and that will give you element 3. Okay, let's do some more. So my list element 1, what would that be? Think about it before I run this code cell. Okay, hopefully you were correct. The answer would be 2. So element number 0 is 1, element 1 is 2, element 2 is 3, and element 3 is 4. Right, and there's in fact some special notation for getting the last element of a list. You can get the last element using the index number -1. So my list square brackets -1 will be the last element of the list, which in this case is element 4. And in fact, it doesn't just work for -1. So -1 will be the last element, -2 will be the element before the last element, -3 will be the element before that, and so on. Again, we learned about slices of strings, and the exact same syntax works for lists. If A is a list, then the slice A square brackets I colon j gives you a list consisting of the ith element, the ith plus first element, all the way up to the j minus 1th element of A. So again, this is the same thing that happened for sequences, for strings rather. If you do A square brackets I colon j, you get elements whose indices were I plus 1 up to j minus 1. So you don't get element number j. As an example, here I've created a list whose elements are the strings A, B, C, D, E, F, G, H, I. And if I ask for the slice of A between indices 1 and 6, then we'll get A1, A2, A3, A4, and A5. Right? We do not get element 6, so we stop at the one before the last thing in our slice notation. So this will give me 1, 2, 3, 4, 5, which is, well, think about what this is going to look like. Pause the video and work it out for yourself. When I do it, you see I get B, C, D, E, F. So the elements at position 1, 2, 3, 4, 5 of my list A. Now, on the PDF version of these slides, or on the notebook version, which I'm going to put on Moodle, there is a link here, right here, to the documentation for lists. And you will find many, many, many Python functions for working with lists. There are ways to sort a list into increasing order or decreasing order. You can delete elements. You can reverse it. There are many, many other things that Python will do with lists. Okay, so to finish off, let's write a function which returns a list of the divisors of a particular number. So here is the start of our function. So on line 1 there, we begin with def to tell Python we're going to define a function. The name of the function will be divisors, and the input, well, there'll be a single input n, which we intend to be a positive integer. And what we're going to do is return a list consisting of all the divisors of the number n. And I've used what's called a docstring here, which is a special kind of comment to describe what the function is going to do. A good thing to do when you write Python functions is to write a very short piece of documentation explaining what the function is going to do. And a good way to do that is to say what the input is and what the output is. So here we said that the input is going to be a positive integer n, and the output is going to be a list of the divisors of n in increasing order. Okay, so how are we going to do this? Well, we're going to store the divisors in a list. So at the moment, let's start off with the output being an empty list, and then we'll add our divisors to that list when we find them. So let's put output to be the empty list. And now what I want to do is go through each of the numbers between 1 and n and check whether they're a divisor of n or not. And if they are a divisor, I'm going to add them to the list. So since I want to check a sequence of numbers, and I know exactly which numbers I'm going to check, a good thing to do here will be to use a for loop. So which should we do? For I in range what? So maybe pause the video, think, what should this range be? Okay, well, I want to start at 1, so I should begin with range 1. And I want to finish at n. So if I want to finish at n, then the second input to my range command should be n plus 1, because range AB goes from a up to b minus 1. So this will get me the numbers between 1 and n. Okay, what do I want to do? So if I divides n, how can I check if I divides n? So I should check if I n% I, that's the remainder when you try to divide n by I. So if this is equal to 0, that's true exactly when n is divisible by I. In other words, when I is a divisor of n. So this is the condition I want. If that is 0, then I'm going to add my I to the end of the output. And we can do that with append I, like this. Okay, so that's all I want to do. That's going to create this output list, which I wanted. So finally, all I need to do is return output. Okay, there we go. There is our function. All right, so that is the function which we wanted. And let's just try it out. So if we do divisors of 6, for example, what do we get? 1, 2, 3, and 6. That looks good. Those are the divisors of 6. So it looks like this is working. Let's do another check. 5, divisors of 5 are 1 of 5. So it looks like our function is working.